I hit record, minimize my GoToMeeting screen. If I say that y varies directly with x, that's true. Okay. If I say y varies inversely with x, that is true. K is just some constant that we don't know yet. Now, if I say there's joint variation, that usually means there's another variable involved, like a z.
Right.
Okay? So, in the third one, excuse me.
Bless you.
Excuse me.
Bless you.
Thank you.
Mm-hmm.
In the third one, what we would say is that y varies jointly with x and z.
Mm-hmm.
Okay? And if I had something like this, I would say y varies jointly with x and z and inversely with m.
So if it's divided, it's inversely?
If it's multiply, it's direct, and if it's multiply with two different variables, it's joint. And that's straightforward. And that's it. Those are the only three you're going to get. Now, you can get some complicated ones. The force of gravity between two objects varies inversely with the mass of the one object times the mass of the other object. Okay, and then there's a K, and there's a couple other things. I don't remember the whole formula. But the force of gravity can be expressed as a bunch of joint and inverse relationships. The most important thing to remember here, if we're doing a direct, if x increases, y increases. If x decreases, y decreases.
Okay.
If we're doing inverse, if x increases, y decreases. And if x decreases, y increases. So it goes inverse with one another.
Okay.
And in joint, obviously if x increases, y increases, and if z increases, y increases.
Okay.
Okay. So you can imagine that there are some relationships in nature that are direct. Like, let me see if I can think one. Person's height and their weight. It's not always direct, but most of the time it is. If you did a sampling of the population of the United States, you would see that the higher, if x was a person's height and y was their weight, then as x increases, usually their weight increases. Okay? I could probably think of another one. If x was the number of hours you studied on a test and y was your test result, then it would be a direct relationship, because the more hours you studied, the better your test result would be. The fewer hours you studied, the worse your test result would be.
Okay.
Okay. This relationship is a good example of an inverse relationship. Force of gravity and the distance between two planets. The further the distance between two objects, the smaller the force. The closer the distance between two objects, the larger the force. So that's an example of an inverse. Probably not a great one, but I couldn't think of a different one. And joint, I don't know, we won't worry about that in terms of an example. Okay, so now let's do some problems. Where do we want to begin here? You tell me.
She assigned me to do 21 through 28.
Okay. So in
We
21,
can start there.
what's that?
We can start there because there's a couple more problems she also assigned me to do.
Okay, let's do the first, and then when we get done with these, you can go from there.
Okay.
So is this a joint, excuse me, is this a direct or an inverse?
It's a direct.
Actually, it isn't. Remember, you need to solve for y. If I solve for y, I get 10 divided by x. This is what you need to be looking at.
Oh.
That's inverse.
Okay.
Not what it starts out that's important. It's what it's equal, what it is once you get y all by itself. Okay, 22 xy equals 1/10.
Well, would that be,
Solve for y first. Always solve for y.
would that be an inverse too?
Uh-huh. It's 1/10 is the k, but the x is in the denominator. Okay, and I could rewrite this as 1 over 10x, but it actually is a little better written this way because this tells you exactly what k is. When I write it like this, it's a little confusing. I got to think about it twice before figuring out what k is. So writing it like this, where you just leave that number in the numerator and divide the whole thing by x, shows you that it's an inverse relationship and also shows you what k is.
All right.
And one of the options is neither. In other words, show whether it's direct, inverse, or neither.
Would this one be direct?
This one's neither. In other words, for it to be direct, I've got to be able to write it like that. I can't write this like that. This is subtracting 1 from x.
Okay.
Okay, so it's got to be able to be written in this form. Now k can be a negative number, k can be a fraction like we just had where it was 1/10. K can be a big positive number, but it's got to be it. I can't have any numbers being added or subtracted.
Okay.
Okay. Next one is y over, excuse me, y divided by 9 equals x.
So, would you multiply 9 by each side so that make it direct?
Correct.
Okay.
Now that's direct and 9 is k.
Okay.
25, x equals y divided by 5. Oh, excuse me. It's 5 divided by y.
Okay, so would you do each side multiplied by 1/5?
Solve for y, first of all.
Well, would you multiply by 5 then?
No, solve this equation for y. How do you solve that for y?
I thought you'd do...
First of all, you got to multiply both sides by y, right? In other words, it's in the denominator right now. We need the final thing to be y equals something. So it's got to end up in the numerator at some point. The way we do that is multiply both sides by y. And that gives me xy there equals 5. Now, solve for y.
Okay, so then you would divide by x.
Now, what kind of relationship is that?
inverse.
3x equals y.
Mm-hmm. So wouldn't that just be y equals 3x already?
You got it. In other words,
Okay.
they were trying to trick you. So that's a direct.
Correct.
In other words, it's already solved for y.
Yeah.
Okay. Now, it is also true, the following is true, which is I can divide both sides by 3 if I wanted.
Mm-hmm.
And now I got x equals 1/3 times y.
Mm-hmm.
And it's technically correct to say x is directly related to y.
Mm-hmm.
In the same way that you said y was directly related to x, but x is related to y with a little different k. Got a k of 1/3, whereas our k was 3. In other words, it doesn't always have to be y. I can say r is directly related to s, like that. So I can have any variable I want on the line. But in the context of these questions, they're using nothing but x and y. So you always kind of want to solve for y. Okay.
Okay.
You said 21 through 28, right?
Yeah.
Okay.
So that'd also be inverse.
Hold on. Solve for y.
Well, you would divide
By
by
5. Is x in the numerator or the denominator?
the denominator.
No, it's not. It's in the numerator.
Well, it should be.
No.
Really?
What do you mean it should be? In other
I
words,
thought it was y equals k over x.
well, hold on. First of all, let's switch these terms. I think that's what's confusing you. Now let's solve for y. Y equals 1/5 times x. So x is in the numerator. 5 is in the denominator. But k is 1/5. But the fact is that x goes up, y goes up. If x goes down, y goes down. In other words, it's only inverse if the variable is in the denominator. It's not just any old denominator. It's got to be the variable. What we had in the denominator was a 5. We had y equals x over 5. Well, y is in the numerator and so is x. That's a direct relationship. Okay? And 28 is x plus y equals 2.5.
So would you just subtract x?
Okay?
And that'd be neither.
Correct. That is neither. Alright, what was next after 28?
I think it was 35 through 47.
Okay? Let me think of the best way to do these. I think I have it. It's also a good way for you to see my new little... Let's see if I can get a picture of these. Good picture.
Okay.
Hold on. Just a second. Now I gotta send it to my phone. I apologize. Should just take a second.
Okay.
Okay. Now let me bring it up on my screen. And yeah, let me blow it up just a little bit. Let me zoom in. Let's see. Let me put all four of them on there. Zoom in again. Okay, perfect. Now, had this capability and I never knew it until just the other day when I was playing around with it. Okay, so if we look at these relationships, we can see that as x is going up, y is going down. Okay.
All right.
Question is it an inverse relationship? In other words, can I say y is equal to some k over x? Well, if it is, then k is equal to yx. Okay?
Mm-hmm.
And if it is an inverse relationship, k does not ever change. Okay? So if the product of those two numbers is the same number, then it is indeed an inverse relationship. And notice that that's equal to 30, that's equal to 30, that's equal to 30, and that's equal to 30. And therefore, k is 30. So that relationship is 30 over x. That's what it is right there. And it's true for every row. And it has to be. In other words, it's not just a question of when x goes up, y goes down. That in itself does not make it an inverse variation. It has to have this other aspect to it also. In other words, k has to be the same number for every pair here.
So it's inverse.
That one's inverse. Let's look at the second one. First of all, can it be either inverse or direct? Let's narrow it down what it might be. And that's pretty easy to narrow down. As x goes down, what is y doing?
Goes down.
That means the only possibility is direct. Okay? And notice that in a direct relationship, it's y divided by x that is the constant.
Okay.
Don't get confused. In other words, you always want to remember that one right there. But algebra is still algebra. In other words, I can still solve for k, and k is y divided by x. Well, if I divide y by x, I get 7 there. I get 7 there. I get 7 there, and I get 7 there. Therefore, k is 7 in every row, and that makes it a direct relationship.
Okay.
Okay, one of these is not going to be, hopefully, and we'll find out. And you'll understand more once we see that. So is 37 possibly direct or inverse?
No.
Neither, and we can see it immediately. For one thing, x goes up, but then it goes down, and then it goes up. Y goes down, up, down, and down. So
Mm-hmm.
we don't even need to do any math on that one. It can't possibly be direct or inverse.
Okay.
Okay? How about 38? Could it be either?
Um, no.
This kills it right there. X is going up and then it's going down. Well,
Mm-hmm.
that doesn't ever happen in a direct or an inverse variation. It goes one direction only.
Mm-hmm.
Both of them go one direction only. It's a question of whether they're going in opposite directions or the same direction. And the same thing with y. Y goes down and then back up again.
Mm-hmm.
So that one, instantly, we don't need. In other words, these two look like they could be direct or inverse. However,
Mm-hmm.
let me make a slight change. Let me turn this number into 6.5. Okay? Over here on the left.
Mm-hmm.
Now we've got x is going up every time and y is going down every time. But this is not an inverse relationship because k is 30 there, it's 30 there, it's 30 there, but it's 32 and a half there.
Mm-hmm.
My k cannot suddenly change.
Mm-hmm.
It's not an inverse relationship if my k changes going from 4 to 5. So it's got to pass more than just the direction test. It's
Mm-hmm.
got to also give you the same k for every combination of x and y, because that's what k is it's x times y
Mm-hmm.
in an inverse relationship. All right. So that's my new little toy.
That's neat, huh?
It actually is. It's far more valuable to me than otherwise. I would have had to maybe take the time out and redraw these tables. By not having to do that, of course, I had to take a picture, which took as much time. But a lot of times students will send me, a drawing or something that I'll have to
Mm-hmm.
redraw in order to go through the problem. And now I don't have
Mm-hmm.
to do that anymore. Now I can just work directly off the image on whatever my computer screen image has on it. I can move it to this little pen app and write on that picture. All right, let me get rid of that. I don't need that page anymore. What else do we got on this next page?
So we have, sorry, I keep losing my, what was that, 35 through
That was 35
39?
through 38.
Okay, so then we have 39
Okay.
through 47, which I think they're different sets of problems, but
39 says a variable z varies jointly with x and y. Give me that equation. How can I write?
y
Hold on.
or z, it's
This
a z
says
equals,
a variable z. Whatever they specify as that first
uh,
variable, that's what goes on the left side of the equation.
okay, z equals kxy.
Yes. That's what it means for z to vary jointly with x and y. Now, they're going to say that find z when x is -4 and y is 7. Okay. First of all, they tell you that when x is 3, y is 8, and z is 6. Okay?
Okay.
What that is going to do, and this is the way these problems are always stated, is that they give you enough information to solve for k.
Mhm.
Then they say, okay, now what is z when x and y are two different values? And you'll know what k is then. Okay?
Mm-hmm.
So let's solve this for k. Tell me what to write.
6 equals k times 3 times 8.
Okay? So what's k equal to?
Well, it's 24. K and then 24 and then 6 on the other side. So what do you divide by 24?
Okay? So what's k equal to?
2.5 or 1/4.
1/4. I hate to see you have to use a calculator to do that, Emma. In other words, we've got 6 divided by 24. Well, I can divide top by 6 and the bottom by 6. I can immediately convert that to that. And that's the answer. It's not really 0.25. I understand those two numbers are the same. But there's never a reason to use a decimal when you can use a fraction. A fraction is always the better answer. So k is 1/4. Now, what is my new equation that I can write specifically for this model?
Z equals 1/4 times 3 times it.
No, times x times y.
Oh.
Remember what the thing said. Z varies jointly with x and y.
Mm-hmm.
So the only purpose of the first part of this problem was to solve for k. Once you solve for k, now you have the specific formula that applies to this situation. In other words, not all direct relationships are the same. This one, k is 1/4. In the next problem, k is going to be some different number. But the fact is, they gave us enough information by telling us what x, y, and z were. That allowed us to solve for k, and now we have the exact equation for this problem. Now the rest of it says, find z when x is -4 and y is 7. So what is...
So we plug in the 4 and the 7 now?
In other words, we still have the 1/4. Now -4 for x and 7 for y. What does that make z?
Would it just be, you divide the -28 by z.
Okay, let's talk about this also. There's some basic arithmetic that you're not doing correctly, that you need to start doing correctly. It'll solve a lot of your problems. When I'm doing that, there's no way I am multiplying across the numerators and then dividing by 4. Because I can see that this 4 cancels with that 4 instantly. When I say cancel, it means leaves behind a 1. And that gives me my answer, -7. I never have to deal with a number that's bigger than 7. Whereas the way you did it, you had to deal with a number the size of 28. And then you had to figure out what 28 divided by 4 was. So you should never do it the way you did it. You should always simplify first. Okay. So the answer here is -7. But let's talk more about this principle. If I have 5 times 7 times 9, and I divide it by 3 times 2 times 4 times 35, I'm never multiplying that numerator and the denominator and dividing the big number by the other big number. Never doing it that way. I'm doing it this way. That's 35, that's 35. That's 8. That's 8. 9 divided by 3 is 3. That's your answer. Never dealt with a number bigger than 35.
Okay.
Okay? So do your math that way.
Okay.
And you will find yourself dealing with smaller sized numbers, and that's going to be a good thing. That's what eliminates mistakes, is when you are dealing with small numbers. 40?
Okay.
Is 40 also on your assignment?
Yes.
Okay.
Yes.
What's the general for these 6 questions? What is z?
K equals, or z equals k xy.
Okay. And again, they give us an x equal minus 12. They give us a y equal 4. And they give us a z equal to 2. That's enough. There's 4 variables there. They gave us 3 of them. That means we can figure out what k is. So tell me what to write.
2 equals k times negative 12 times 4.
Again, I'm not going to multiply those yet. I'm going to divide both sides by negative 12 times 4. Okay? Now I can divide that by 2, leaving behind a 1, and I can divide that by 2, leaving behind a 2. And now k is equal to 1 over negative 24. And again, notice that had I multiplied that together immediately, I would have had a big number, 48, that I would have had to deal with. And I avoided dealing with that big number by doing it the way I did.
Okay.
Okay, now give me the specific equation for this question, question 40.
Z equals negative 1/24 xy.
Good. Now in this problem, also they want you to solve for z when x is minus 4 and y is 7.
Okay. So then you would just plug them in.
Okay, which I'll
And that's...
do here. Now, again, can we simplify that before multiplying it together?
Yeah, you can simplify with the negative 4.
Well, I can certainly cross off both negative signs, right? In other words, the negative times a negative is a positive, so I don't have negative anymore. And I can divide top and bottom by 4. Makes that a 1. What's this divided by 4?
6.
And there I have my answer, 7 over 6. And that's what z is equal to.
Okay.
Okay. So, now, the question is, we've got 25 minutes. You're supposed to do 39 through what?
47, I think.
Well,
Yeah.
41 through 44 are exactly the same.
Well, I know she assigned 54 and 55 as well, and those are word problems.
Okay.
I didn't understand those.
Let's do 45 through 47, and then we'll do the 2 word problems, and then if we have time, we'll go back and finish up these other. I think you get 39 and 40, am I wrong?
No, I get it.
Okay, so I think you'll be able to do 41 through 44 pretty easly. And I just don't want to spend our time doing problems that you know how to do. Let's go to the ones that you might not know how to do. So, how would I write an equation for 45?
Well, hold on.
Well, goes on the left side of the equal sign?
Oh, the x varies inversely, that one?
Isn't that your 45?
Yeah, so it would just be the
What goes on the left side of the
y or z.
No. What's the first letter you see?
X.
That's what goes on the left side of the equal sign.
So x equals yz.
Equals what?
Yz.
Well, first of all, it varies directly with z, so z's got to go in the numerator. It varies inversely with y, so y's got to go in the denominator, and I'm missing a k. Where's the k go?
In the front.
Well, that's in the numerator. In other words, k is always in the numerator. Notice that when we had y varying directly with x, k is in the numerator. When we had y varying inversely with x, k is in the numerator. So k is always in the numerator, or in this case, you can say it's out front, but that's in the numerator. Just it's not in the denominator is the important thing. Okay, so what about 46? Goes on the left side of the equal sign.
So y
equals
k over x, or the square root of x.
Just a second. Do you see the word inverse anywhere in there?
No.
So it varies jointly with z and x, but not just any old x, the square root of x. So that's how you write that. In other words, if it doesn't say inverse, then you can't stick anything in the denominator. It's basically telling you that it varies jointly with z and x, but not just x, the square root of x. And that's fine. You can vary jointly with z and the square root of x. Or even, you could say, if I had another problem, y varies jointly with z and x squared. In other words, that's what I would say if I had that. Y varies jointly with z and x squared.
Okay.
Okay. So how about 47?
W equals,
go ahead.
Would it be
Start with your k. In other words,
kzy over x?
Yes. kyz over x, because it's varying inversely with x, but jointly with y and z. And jointly essentially means directly. It's the same as directly, only there's two variables instead of just one.
Okay.
Okay? All right, now let's look at what's the first word problem?
54 and 55.
Okay.
Those are both of them.
Okay.
And she did not teach us how to write them at all.
It's fairly straightforward. First of all, they're telling you what's on the left side of the equation, intensity.
Okay.
Right. Varies inversely with something, so there's definitely a denominator. I got a k that I know is going to go somewhere.
Okay.
But varies inversely with the square of the distance from the sound's source. So d has to go in the denominator, but it's d squared. You see how that fits the first entire sentence. The intensity varies inversely with the square of the distance.
Okay.
Okay. Now, it's going to give you similar information that we got up in questions 39 through 44. it says that at a distance of 1 meter, in other words, when d is equal to 1, the intensity, I, is 10. And I'm going to ignore units for a moment. Just usually they don't mess with units on you. So
Okay.
you don't need to worry about units. What's this going to allow me to calculate?
K.
Okay, so what is K going to be? So I get 10
1/10.
K over 1. Hold on, solve that for K.
Well, 10.
Okay. K equals 10. So now my specific equation for this sound system is that. My intensity is 10 divided by the distance squared. Okay, so now they're going to ask you another, they're going to say, write an equation relating I and D. We did that already. Now the last sentence says, if you were sitting 15 meters back from the stage, what is the intensity of the sound you would hear?
Well, 225.
Give me the equation.
I equals 10 over 225.
Okay, notice that's a different answer, right?
Mm-hmm.
Okay, so in this case, in the last case, when we were sitting only a meter away, we had an intensity of 10. Now our intensity is, I can divide both of these by 5, so I get 2 over 45. So our intensity is down to 2/45. That's a huge drop-off.
Mm-hmm.
Why everybody pays the big bucks for the front row.
Yeah.
Seriously. If you go to a concert, you'll pay a lot more the closer you get to those amplifiers. And the reason is illustrated by this problem. That intensity, by being inversely related to the distance squared, well, that means I don't have to go very far away if I'm squaring that number. 15 feet squared was 225, so it dropped off seriously even at 15 meters.
Mm-hmm.
All right, what's the next word problem?
55.
Okay. Again, these sound hard, but just always start with that first variable that varies something.
Mm-hmm.
Give me the rest of it. Now notice that I didn't worry about units on that last one. I'm not worrying about them on this one either.
W.
They're not going to mess with units. In other words, they're not going to give you a mixture of units and make you convert them. If they did, they could, but no, they're not doing it at this level. So read the rest of it.
Well, it's jointly, so it's multiplied by x
So
and
give
y
me the
and
equation.
another one.
Give me the equation. The question says,
Times.
equation that relates W, M, and H. So that's what I wanted.
So
Equation that
times.
W, M, and H.
So times m and h.
What about K?
K, m, and h.
K, M, and H, because it varies jointly with the mass and the height.
Mm-hmm.
Okay, well, there's our equation. Now it gives you some conditions. The work done when a 120 kilogram object, well, what variable is that?
W.
No, notice that it says the work done. When a 120, that's the mass. So it's K times 120. The work done when a 120 kilogram object is lifted 1.8 meters. So the height is 1.8. Okay. And they're saying the work done is 2116.8 joules.
Okay.
They have given us W, M, and H. And
Okay.
granted, you really don't have any way of knowing that they were giving you the mass, but the key was that the work done is, that means W hasn't come yet, right? When they say the work done when A blank, that means they have not given you W yet. But then the blank is lifted 1.8 meters. The work is 2,116 joules. That's a measurement of work. And now we can solve for K. Okay, so K is going to be this number. This time it's okay to use your calculator. I don't mind you using your calculator when they give you big numbers like this. And it's okay to get a decimal. In other words, whenever you have to use your calculator, a decimal answer is just fine, because that's what your calculator gives you, especially when we got decimals to start with here.
9.8.
Okay, exactly. There's no other decimals after the 0.8?
That's what I got.
No, that's fine. I'm not checking your work, so I just didn't know whether you were rounding off to the nearest tenth or there were more decimals to go. So,
You know, my calculator's on a weird setting.
oh, so it only gives you one decimal.
Yeah.
Oh, okay. You might want to change that.
Yeah.
One decimal isn't really generally enough. Plus, most teachers will always want it rounded off at least to 2 decimals.
Yeah.
Rarely do you round off to 1 decimal.
And
you don't want your calculator automatically doing that, because now you have no way of getting what the number would have been if you'd rounded off to 2 decimals. And we may be losing accuracy because of it. So, okay, so now what is my specific work equation for this?
W equals 9.8 times M and H.
Okay. Now they ask specifically, how much work is done when lifting a 100-kilogram object 1.5 meters? So what's the next line?
Well, what's 8?
Look, well, first of all,
Well, H is 1.5.
read the thing. Write an equation. How much work is done? What variable are we going to have to solve for?
W.
Okay. So they're going to give us M and H to come. Okay. So I get W equals 9.8. What do you suppose M is?
100.
Okay. It's got to be, doesn't it? There's only one other thing, and it's a height. It's measured in meters. So anything measured in meters is going to be the height. And it turns out that kilogram is a measurement of mass. Okay, so the work done is the product of those 3 numbers, assuming we didn't lose any accuracy by rounding off to the nearest tenth. That could be 9.84. You don't know. And then the amount of work done is going to be significantly different. So this round off stuff is not trivial. It's important. You want to make sure you get your calculator set so that it gives you all the decimals and it doesn't round off to the tenths place.
Okay.
Do you have a TI-84, Emma?
Yeah.
I think you just
Inspire.
Oh, it's an Inspire? Well, I'm not positive how to do an Inspire. On an 84, you just go to mode, and you can set how many decimal places it's going to give you.
I think it's just under settings.
Yeah, you play around with it. I don't know how to set it on an Inspire, but it shouldn't be hard to figure out. You want to definitely change it. You do not want to typically round off to the tenths place. That's not enough accuracy usually. And you can tell in this problem, it's going to change the answer. In other words, I don't know if it was 9.80 or 9.84 or 9.83. But obviously those extra digits, we're multiplying by 100. and then again by 1.5. So those extra digits are going to become whole numbers. So what'd you get for work when you multiplied these three numbers together?
Well, it did end up whole since, like, it didn't have any decimals after it.
Would you get what number for?
1,470. Because 1.5 times 9.8 was 14.7.
Okay. Okay. And that is in joules.
Yeah.
That's one of those strange units that you're probably not familiar with.
It's in chemistry and physics.
Yeah, if you've taken physics, you'll be familiar with joules. But joules is work done in the metric system. Work done in the English system is in foot-pounds. And foot-pounds make more sense because notice that H is in feet and mass can be in pounds. And so work, if mass is in pounds, if you take 100-pound weight and you lift it up 2 feet, then the amount of work done is 200 foot-pounds worth of work. So foot-pounds to me makes more sense than joules. You always got to remember what joules is, where foot-pounds makes a whole lot more sense. And K does not have any units on it. K is a constant. It's just a number. There's no units. In other words, in this problem, 100 was kilograms, 1.5 was meters, so I ended up with kilograms times meters. That's what joules are, or kilogram times a meter. It's 1 joule. Okay? You got any other word problems? We got 5 minutes. If not, we can go back and finish up those other 3 problems.
That's it for the word problems.
Okay. So we need to go back to 41, right? We didn't do 41?
Yeah, 41 through 44. Okay. Or 47.
So again, starting with the instructions, Z varies jointly with X and Y. So I can write it like that. And 41, they're giving us an X that is 1, a Y that is 1/3, and a Z that is 5. Tell me what to do.
5 equals K times 1 times 1/3.
Now what?
Multiply each side by 3.
Now what?
And then that's it.
Well, it's not the whole problem, though. In other words,
yeah, well,
we want an equation specific to this problem. So you got to put it back in the form of Z equals what?
15xy.
Okay, that's the specific equation. This is a general equation. This is the specific equation, meaning we've solved for K. And now they want to know what is Z when X is -4 and Y is 7. Set it up. I'm not as concerned with the answer as probably you are, but I always think it's better to set it up before you do the math. In other words, write this step like I've done there. Whenever you try to do multiple steps at once, and I don't mean you, I mean anybody, whenever you try to do multiple steps, you're just asking for mistakes. If you want to eliminate mistakes from your math, then do everything one step at a time and write it out. Okay? Now this one, there's no simplification because there's nothing in the denominator. So it's basically -60 times 7 minus 420. That's what Z is when X is -4 and Y is 7. Okay, let's look at 42. Starting with the same general and the specific conditions on this one are going to be, what are we doing? 42 minus
Yes.
3 and 2/5. Tell me what to write.
2/5 equals k times -6 times 3.
Now, I still like doing it this way. In other words, I'm going to divide both sides by these two coefficients, right?
Okay.
And that is this. 5 is still in the denominator, and both of these numbers now have to go into the denominator, because I'm dividing both sides by those two numbers. Okay? Now notice that I can do a little cancellation with this 2 and the 6. What can I do?
1 over -3.
Okay. Now k equals what? 1 over
-45.
Good. Now what's the
Could you flip it and could it be
nope,
positive?
Nope. It's whatever it is, okay?
Okay.
And it's not a negative over a negative. If it was a negative over a negative, that'd be positive. But I only have one negative sign here, and that's in the denominator. Now, that's the same as minus 1 over 45. It doesn't matter where that negative sign is. It can be in the numerator, it can be in the denominator, it can be out front. They all mean exactly the same thing.
Okay.
Okay? So, what's the specific equation for this model now?
Z equals k, or I'm sorry, my goodness, 1 over -45
Put
xy.
the negative sign out front. I actually like that better. Like that.
Okay.
Does mean the same thing. I don't have to do that, but I'm going to, just because I'm more comfortable with it. And I suppose it doesn't really matter whether you put it out front or with the denominator. That's just my preference. There's nothing magical about it. Okay, so now they're giving us, this is the specific, and they want to know what z is when x is -4 and y is 7.
So that's just -28.
Hold on. What's the first thing I can do before I do anything else?
Cancel out the negatives.
Okay, good. I can cancel them out by just doing that. Okay? Now, you're right. There's no way I can simplify. There's nothing that goes into 4 and 45, and there's nothing that goes into 7 and 45. So I end up with 28 over 45. And again, there's nothing that goes into both of those numbers, so I can't simplify that. That's as simplified as it gets. That's what C is. All right. Okay. I am going to have to quit you with these two last problems to go, but I am totally confident you can do them.
Okay.
43 and 44. All right.
Okay, thank you.
All right. Have a good weekend. I will talk to you.
You too.
Next Thursday.
All right. Bye.